Pythagoras. In my mind, Pythagoras was the very first electronic technician. Yeah, we didn't have electronics back then, but it was his mindset. Indeed. Whenever you're around an electronic technician and you say something that doesn't make sense, you do something that doesn't make sense, or you observe something in the natural universe that doesn't make sense, they usually look up and go, no, that didn't make sense. And nothing can stop them from just sitting there and trying to figure it out, and they won't stop until they make it work. Pythagoras was that way. People would come up and go, and you know the earth is flat, don't you? And Pythagoras goes, no, that don't make sense. You take a pole and you stick it way over here, a really tall one, and you get under it and you start walking away from it. And the further you get away from it, the less and less of the pole you see. But that wasn't enough for someone like Pythagoras. Of course, he was a little bit more than your standard electronic technician, philosopher, mathematician, general mental giant. He actually figured the math out and the science to it all, and actually told the entire universe, all of Earth that is, nope, it ain't flat. It's a globe. And he proved it. Here we come to the Pythagoras Effect. Did Pythagoras have this? What were the chances that he actually got it right? So we went from being flat and riding on the top of a turtle through the universe to being a sphere, yet still the center of the universe. Not right. And it stayed that way for quite a while until Galileo came along. And all those telescopes started pointing at the night sky, and Galileo said, that doesn't make sense. If all my calculations are correct, the Earth is actually going around the sun, and so are all these other planets and stuff. Did Galileo have access to this? What were the chances he got it right? And he didn't. It went to the sun being the center of the universe. And it was that way for some time, and then they realized with all those telescopes that our sun was a star that was part of a greater group of stars, and we called it a galaxy. And they came up with the steady state theory. And our galaxy, the Milky Way at the time, was the sum of the known universe. Did they have access to this? What were the odds that they were going to get it right? And they didn't. We seem to keep getting closer, but still, you don't have all the data. Then comes along the dude that came up with the Big Bang Theory. Did he have access to this? What are the odds that he was going to get it right? And did he? Nope. He didn't. It's the Pythagoras Effect. Level 1, flat Earth. Level 2, Earth the center of the universe. Level 3, Sun the center of our universe. Level 4, the steady state theory. Level 5, the Big Bang Theory. Welcome to level 6. We've got access to this. And for the past 20 years since we've had the thing, people have been trying to make this fit the Big Bang Theory, which is incorrect. I mean, everything about that theory is incorrect. The guy that came up with it didn't know anything about space. He got us closer than we'd been before, but he still didn't have this. Look at this image. If he would have had access to this image, do you think the word bang would have come out of his head? Man, no matter what angle I look at that thing, there ain't no bang. He hypothesized that all of the matter that there is, we're talking 10,000 galaxies here alone, was all in one spot. And because he didn't know anything about main sequence stars and what happens when you get a tremendous amount of mass in one spot, he speculated that all the matter that there is was the size of an atom, and then it went boom. Well, that's insane. We all know all you need is a magnitude 3 or larger star, and it's going to end up a black hole. Much less all of the matter that there is. If all of the matter that there is was in one spot, I guarantee you, you would get a black hole. A really, 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 really big one. It's not going to explode. It's going to implode. All right. Level 6. I lovingly call it the Great Fling Theory, and I'm going to do it again one more time here. All right. It's just a hypothesis, folks. It could be wrong, but it's going to be closer to the truth than anything we've done before, because unlike everybody else that looks at this, I'm actually looking at it. I'm not trying to make it fit some preconceived notion from someone that knew less about space than today's third graders. So, without further ado, the Great Fling Theory. All right, this image here is so absolutely amazing. I never get tired of looking at it. You could say, well, the most amazing thing is this or that, but really, that galaxy that's actually way back there, incredibly red, it's going much slower than we are. It's going much slower than everything else in this image, as a matter of fact. But the thing about it is that it is 400 million years old. So, whatever happened, the first thing, happened at least 400 million light years past that galaxy. Look at it. Look past that galaxy. What do you see? All I see is black, which made me ask a question. Is there anything that we know of in this universe that is absolutely black and yet is capable of flinging massive objects around as if they were tinker toys? There is. There's something we actually know. There's an answer for that. It's called a black hole. Only in this case, if it did this, it's going to be a big one. Really, really big. Funny thing that, if all the matter there was actually in one spot, the black hole, it would create a really, really, really big one. Bigger than anything we've ever thought could exist. And you've been looking at it for 20 years and you haven't seen it yet. Look, here we are on the way out. And we got a long way to go. Here we are, 14 billion light years away from this thing, and we may have gotten 10% of this journey done. All these galaxies are going to go out to the very furthest edge of that thing's gravity well. And it's going to take 150 billion years. It's hard to speculate. It's as they get further out, it will start slowing down, but it'll also run out of neutrons. Because that's what's happening here. We're literally making neutrons out of protons. And once we get way out there to the very extremes, everything's going to be used up. There's going to be nothing but burnt out husk, dust, debris, and black holes. And then all the lights go out and it gets dark and everything starts coming back down. And for the longest time, maybe 200 billion years that it takes it to get all the way back down, everything's going to lose atomic cohesion because of absolute zero. There'll be no light. Rather than wait that much time, why don't we just back this bad boy up about 15 billion years? What you'll have is a big black hole right in the center of the universe, area of no return, so to speak, and then the primordial disk. From the last oscillation, everything had come down and it was nothing left but hydrogen. H2, everything came apart. Let's say you had an asteroid way back when, and it was froze with absolute zero. Eventually the iron and stuff would just come apart. It wouldn't stay together. It would come apart. And even the iron itself, the atoms will come apart from billions and billions of years of exposure to the long, cold dark. And you end up with the primordial disk, a hydrogen belt going around. And it is dark here. There's no light. There's almost a negative light because of the black hole that's in the center of our universe. And everything's going around here. The leading edge of that primordial disk is being held out of the abyss by the gravity of everything else that there is. All of this stuff here broke down to nothing but hydrogen. The trailing edge slowly coming in, and all the stuff there is ends up in one massive belt. It kind of looks like Saturn, only it's a solid belt and there's no light. As the trailing edge comes in and the leading edge is barely being held out, it actually gets a noticeable gravity. It makes its own gravity. And when it gets enough, the leading edge and the trailing edge actually catch a wave. And the whole thing kind of goes whoop. And then there's this tipping point. A spot where there's just way too much stuff and way too small an area. And seeing how it's all of the stuff that there is in a big band around here, there's this tipping point where it can't be contained. Day one. Baby steps. These super massive stars burst into life. These things are bigger than any stars we see today. Super duper, super hyper giant stars, because there's just so much stuff. And there are billions of them. Billions and billions of them all the way around here. Something like 350 billion, give or take 4 or 5. And what didn't get turned into a star gets captured by a star. These are actually embryonic galaxies. It's the first thing that happens, galaxy formation. What really amazes me about hydrogen is just how fast that stuff flows in a gravity well. You see it when a star itself ignites. A tremendous amount of hydrogen has to fall in very quickly for a star to ignite. So it was boogieing pretty good going around the big black hole, but when these things burst into life, well, that's in a tremendous amount of mass in one spot. And the speed they're going just doesn't quite hold, and every one of them change course just a little bit and start moving out. Thing about them is these things are so utterly enormous that they only last about 10 million years. They burn through their material very quickly, and suddenly they hit lead and boom. Day 2, the breath of God. I'd like to describe it some other way, but I simply cannot. When these things implode, they've done a few things. Because they're so immense, they actually had the CNO and the outer materials blown out into the rest of the galaxy. the embryonic galaxy and all that H2 suddenly gets mixed with a bunch of CNO. But in the middle of it all, a black hole just appeared. And the resultant gamma ray burst that come off of this thing, 350 billion of them, all the way around it. It's a really bad day to be anywhere near here. It's like God went, let's get this party started. All the way around. So many gamma ray bursts that we're still seeing them until today. Man, a good creation of the universe theory should answer questions. Where did all those gamma ray bursts come from? Well, when this thing got going is where they came from. And not only that, but now you start getting this rotation in your embryonic galaxies. Day 3, let there be light. Rotation, wow. Some of the stuff in every one of these things was just a little bit too close to that black hole, and they went down fast, so fast, in fact, the light coming off of it causes what we call quasars. And man, it was like God's flashlight. 350 billion quasars. So many quasars that we're still seeing them until today. Just keeps answering questions, you know. And we really get our spiral going now. All right, everything's going. We're actually infant galaxies at this point. The spiral's good enough. It wouldn't surprise me if stellar formation started in some of these things. Okay. Day 4, moving day. What used to be a tremendous amount of mass taking up an incredibly amount of space suddenly became a tremendous amount of mass taking up a little bitty spot in comparison. They're actually pretty good sized black holes. How big do you think these stars were, Carrie? Well, if you take the supermassive black hole that's in the center of the Milky Way galaxy, now I've heard that it has merged with as many as 3 or 4 other galaxies. Okay? So let's just say the Milky Way galaxy is the sum of 4 of those. Okay? So you take that black hole in the center and you break it into 4 pieces and you say, how big of a star would it take to create that big of a black hole? And that's how big these stars were. And the speed that these things were now going were nowhere near enough to hold that much matter in that tiny space, and every single one of them went from doing this around the black hole to doing this. It's a gravity assist. They change their vector and start going out, and as they move away, there's less gravity from this thing, so they pick up more and more speed. And they'll get to a spot on the gravity well of the big black hole in the center of the universe where the gravity well created by the primordial disk actually pulls the lip down a little bit. Just like we use the trailing edge of gravity wells of Venus and the moon to speed up our satellites, this thing pulls it down, and every single one of them get an extra little fling. And here we are. It's a gravity assist. It actually explains how come we're so fast, so far, going so fast. I keep hearing people say that we're further than we're supposed to be. No, we're not. We're exactly where we're supposed to be. You can tell, because here we are. Now, this is my hypothesis. I call it the Great Fling Theory. Okay? With this theory and me thinking about it for 20 years now, I wish I could get some physicists to do it because they're actually physicists. They probably do all kinds of cool things with it. Me, I'm a little old country bumpkin, electronic technician that doesn't really know diddly poo about diddly squat. Look at it, open your minds, come up with your own theories. Mine might be wrong, but I guarantee it's closer than anything we've got before because I had access to this. Okay? And it is remarkable. Because of my access to this and me thinking about it, I actually had two other theories just drop in my lap. I call one the neutron dance. It's in one of my other videos called The Dinosaurs of Physics. And the other one is a theory about what causes gravity. Just fell in. I wasn't looking for this stuff. I'm not a physicist. Imagine what would happen if we got physicists to have the correct foundation with the stuff they have in their minds. They're actually thinking about this stuff. This is a hobby for me. Boy, do I love it, though. Whether this is right or not, the Great Fling, it's definite that the Big Bang is wrong. Okay? Welcome to level 6. Let's get to work on it, folks. Stop doing that archaic, ancient thinking and wasting time and money on things that try to keep that damn thing going, like dark matter and dark energy. Or as I like to call them, mystical, magical, dark fairy dust. Cool thing about the Great Fling theory, it doesn't need any of that stuff. It actually works. It doesn't break the laws of physics, like trying to get all the matter that there is in one spot, the size of an atom. It's just insane to me. So, if it doesn't make sense, use the Pythagoras Effect. Go, hey, that don't make sense. And try to make it make sense. If you keep doing the same thing over and over again, you're not going to get anywhere. Anyway, whether it's right or not, welcome to level 6. Or stay a flat earther. What's the difference between a light bulb and a pregnant woman? You can unscrew the light bulb. I love that joke. You see, unscrewing a light bulb is physics, and a pregnant woman is, the consequences of your actions, which is. I thought it was funny. Peace out, folks.